Hello folks, it's David T and of course Miss Elizabeth, and we're back to show you how to get into the nitty-gritty of the PS-3010. This video shows how to replace potentiometers at the top of the power supply. Always practice safety when you're opening a power supply. Remember that there are capacitors in supply units. Those capacitors store energy, and some of the energy in a switching power supply, which is what the PS-3010 is, can be quite shocking. Let's begin. Now, first of all, we're going to take the case off of the PS-3010. For me, I use an electric screwdriver. Take the front knobs off. Now those knobs on the front simply pull off. They pull straight out, so just simply pull the knobs straight out. Behind those knobs are some nuts holding the knobs to the case. Once you take those nuts off, that front daughter board will simply come out into your hands. Be careful when taking your case off. I have had to replace my 10K because I accidentally broke it. Let that be a word to the wise. Those potentiometers, a wire wound 10K 10-turn potentiometers. Putting too much pressure on them, you can crack them, break them. It's actually very easily. I thought I would share with you that mine has to be replaced. The modification has already been completed on this unit. All I'm trying to do is show you what the process that I do this. I have placed the new potentiometer into the drilled hole. Now those holes that you drill in this will be up to 3/8 inch hole. When you go to drill your holes into the case, now I'm not saying you have to use the case. If you wish, you can engineer up your own devices or device to hold potentiometers. You know, you might even make a separate kit that plugs in to the power supply. It's strictly up to you. That potentiometer has been replaced and hooked Fluke 87V VOM. We put it on the ohms reading. Just the potentiometer is working correctly. Now, for those who are still learning how potentiometers work, this potentiometer has common, then it has an input, and then it has an output. As you vary towards one direction, resistance on one side goes up. As you vary the other side goes down. Turning the unit around to give you a better view of where everything is hooked up. Trying to turn everything to the camera to get you a good close view of that daughter board as it is connected to the front case. Taking off the last of the nuts, you'll see that daughter board comes straight out. Use something sharp. There is an adhesive that connects and holds that connection to place. You'll have to break that loose. We have a desoldered. One potentiometer is, of course, the V course. The other one, which is a 6-pin, and we're showing you that there are 6 pins to this potentiometer. You'll also have to desolder those from a dual-sided daughter board. I am rewiring the case due to that error that the potentiometer made. Now, if those who are still learning how to solder, get on YouTube and review the practices on how to solder or desolder. Now remember, desoldering a dual-sided circuit board is a lot different from desoldering a single-sided board. For me, I use a desoldering tool or a desoldering gun. If that doesn't work for you and you cannot find one available, well, here we're showing that you can also use solder wick. Desoldering on that daughter board, do not let your iron get too hot that you'll burn the board. The board is quite flimsy and Speaking from experience, you can't burn the board. You can burn the trace. Burning the trace means now you're going to have to act like a technician and fix that problem. Showing you now how to take those two pinchometers that were removed from that daughter board and we're placing them right back in the case. You might be asking, why am I doing that? My answer is, why did the chicken cross the road? Because the road was there. That's the only reason why I put them back, for aesthetic reasons, just to make the power supply look nice. I didn't want to have large gaping holes in the front. Put those pinchometers back in place. Always turn the leads to the center of the board. In other words, you want to keep those pins away from that daughter board so that it does not make contact. Finally, putting those two pinchometers back in place. Now you don't have to make them too tight. They're simply just pushing the knobs back on. There's a wire that we have to make sure that we reconnect back to the daughter board. Don't forget that wire. If you do, then your control adjustments will not work. I'm just simply putting the case back on, making sure that none of the wires were disconnected or broken in somehow or some fashion. The case does go right back on. Then grab your trusty electric screwdriver and just simply put the case back together. Set up that power supply, turning the knobs all the way over to the low side. Next thing we want to do is go right back up to the 500 ohm knobs and turn them 5 times. We're doing that so we can set those pinchometers in the middle so that when you adjust for fine, or what I call double fine, then you'll have 250 ohms one direction, 250 ohms the other direction. That can give you your precise adjustments. Putting the AC cord back in and turning the unit on. And you see the unit come on. Now with those 500 ohm knobs turned down, and also the current knobs, the fine tuning current and the coarse tuning current, adjust them high. See the green light come on the voltage area. That means that now you have enough current to start the power supply. Adjusting that power supply, 10 volts, and we're showing you that we can adjust all the adjustments and to make it a precise adjustment. We're going to be putting a VOM, that is the Fluke 87V volt ohm meter, and it will show us if we're right on the spot. Putting the probes together and hooking it to the VOM, you're going to be surprised to see that we are spot on. There is a 0.01 difference that I do notice. You can get quite close to the adjustment of that, but anytime that you go over 0.01 voltage, you're going to see the Fluke 87V move up just a 0.01 higher. That change does stay pretty much the same all the way through the spectrum of that 30 volt power supply. Yet I did notice that as you go down in voltage, that it begins to steady itself down. In other words, the readings are quite precise. They do match the Fluke 87V. We're showing that the power supply does go up to the 30 volt DC. It'll be right on it, and you actually can get about 32 volts out of it, which is more than the manufacturer is stating. That's how we do that modification. This is David T, and of course, Miss Elizabeth, telling you thank you for watching. I hope you have a wonderful day. Bye-bye.
Hello folks, this is David T again. Well, we're working with the PS-3010, the modification, and after I completed my modification and tried to change the connection wires, I've made some type of mistake. So here we are working on that problem. So first of all, what I'm doing is I'm taking off the pinchometers, and then I'm going to check my wiring on the audio board just to verify that I have not made some type of mistake, which obviously I have. Okay, so I have desoldered all the wires on the pots, and I'm going to change the big gigantic word pinchometer to pots. And then next I'm going to check, make sure that the pinchometers have not failed on me. So that's the next thing we're about to do. And we have verified that the pots are good, so it must be a problem in my wiring. So now I'm going to recheck my wiring, make sure that my wires are good, and then we'll check the 6 pins. So here we go. I'm checking my wiring. Now make sure also that when you are doing your test, that you have some good connection leads. And I am on the middle lead, that should be good. I'm going to put my VOM on continuity. And there may be the issue. Well, I thought I would show you the problem, and it was my mistake. It's a very simple mistake, but it caused a little bit more time to put in it. These, for me, I tried to make a color code so I would remember what wires went where. And if you might notice, we can try to zoom in. See if I can zoom in for you. And you'll notice that the white wires are the common. They're the center of the pots. Well, what I did was I grouped everything, and unfortunately I put my center common wires to the wrong group. This center wire was put with this group, which is the wrong group. The group I'm supposed to be working with are this wire, or these three. So I'll group them together now. So always let that be a lesson to do things before, not after. No, I just did it wrong. It's supposed to be, there we go, this blue, this white, and the color code that I've obviously made was red, white, and blue. Okay, now we'll group those the right way, and then we'll group these, the other pair. Now this of course was on the 500 ohm pots. And there we go. Well, that was my problem, as you can see. Have a good day. Thank you for watching.